Okay, so the next series of videos are going to be talking about Newton's laws of motion, and they're basically going to be broken down into systems. So what is a system? The different types of forces, then the three laws of motion, and then there's going to just be a bunch of example problems and some other topics sprinkled in, such as friction. There's a problem-solving strategy, as well as drag force, because in Physics C, we do have to apply the drag force concept every once in a while. But so in this video, we're going to talk about systems. And one thing to remember is that in the previous unit, right, we really learned how to describe the motion. And so the description, again, we talk about how this is duck-on-pond physics, right? Let me just kind of change this setting real quick. Okay, so kinematics is really our descriptor, right? So how fast an object is moving, how far does it travel, right? And so when we just, whoa, I did it again. Let me change this setting. So kinematics, right, is our descriptor, right? It's how we describe, it's how fast, how far, how long. Okay, and the great thing about this type of physics is that we do look at constant acceleration. And remember, I kept calling it duck-on-pond physics, right? So, and pardon my drawing, right? It'll look like a dinosaur probably. So here's our duck, right? There's its bill, here's its feet, right? And so we are up here, right? So this is our kinematics at this point in time. We're on top of the pond. We just like how the duck floats around the pond beautifully, right? We're not worried about underneath that his feet are going back and forth. You know, there's plants down here, there's sea life, right? And then he's kicking it, there's rocks, okay? And he's pushing it away as long, okay? That's where we're gonna go now, right? So this is like what is happening, okay, up top, right? And this is how it is happening below, okay? So that's kinematics, and then we're going to focus here, right, in a topic called dynamics with Newton's laws of motion, right? So that's our duck-on-pond physics. I kept telling you guys about, or keep saying that because the students will try to read too much into kinematics, and it's like, no, just believe what's on the surface, right? It's just that duck floating around on the surface. It doesn't matter. They're kicking things below, how they're getting pushed around up, on it, but now we're going to go under the water, right? So now we're going to dive under the water, and we're going to see how do the feet play into it? How does the fish play into it? Okay. So the first thing we need to do is that we do need to establish systems, right? So when you do these problems, we need to focus our attention on something. And what do we focus that attention on? It's our system. Okay. And so the system is the object that we're choosing to analyze. And oftentimes it's just simply, what's in the problem, okay? So anything that comes from outside the system, okay, or from the object that we've identified as our system, that's our environment, okay? And now this is going to this consists of objects that might interact, okay, with our system or with that object. So, for example, let's say, and this is a classic AP problem, you got two blocks being pushed on a surface, right? So one way that you can treat this problem is to call the two blocks the system, okay? And you'll see here in a second why we're going to call the two blocks the system. And then this pushing force here, this force that's pushing them, right? That is coming external. So that is coming into the dotted circle, and that's what is going to cause the change in the motion, right? Because you can see these external interactions, okay? That's what's going to affect the motion, okay? That's what's going to change the object's motion. And so what we call these interactions that come from outside, very simply, they're just called external interactions, okay? or external forces. You'll see when we talk about Newton's laws, we'll talk about these unbalanced external forces. Okay, so now what do forces really do? Well, first of all, they're going to touch the object, right? So if I'm pushing something, I'm physically touching it, which causes me to push the object, right? And then also, it's going to cause me to pull the object. Okay. In fact, the last two bullet points here, that is the definition of a force, right? So a force is a push or pull on an object, right, that causes changes in its motion. All right. Now, what happens is sometimes a system has parts. Okay, so like if we say a car is a system, the wheels of the car, the axles, the engine, those are all we call internal, right? So the components of the car, if the car is a system, those are internal. Okay. And now, when you talk about these internal components, those forces that we don't have to worry about those unless we're looking for them individually. And I'll go back to our box example here in a second. Okay. So now, since these components of the car are inside the system, these are what we call internal forces, okay, or internal interactions. And these are ones that, for the most part, you can ignore if I'm trying to find like the acceleration of a system. Okay, so if I'm looking at, let's say the problem, if I go back to my boxes here, if I'm talking about what is the acceleration of the system, right? This has a mass, this has a mass, right? So I can do a little calculation to figure out the acceleration of the system. But knowing that these two forces, there are these two objects, that mass 1 and mass 2 are internal or are touching each other, okay? The way if I set my system up like this, yes, M1 will exert a force on M2, and M2 will exert a force on M1. But if I'm looking at the entire system, I can ignore those forces because they're inside the system. But now if I'm looking at what is the force on M1, well, now I can treat M1 as its own system. It's being accelerated in a way, and then I can do the same thing for M2. Now these forces matter. Okay, now those internal forces are no longer internal to the system. Now they're external to the system of M1 and M2. We'll get more into that later, but you can change the system according to the problem as needed. Okay. Now, in the next video, we'll talk about the different types of forces. Okay, and this is going to be a handful of forces that are most common in problems, where we're just going to do kind of a surface dive. But then we'll talk about some of them at length and a good amount of them in a bunch of example problems. Okay.